Now, what you've already learned is that the DNA molecule is a double helix composed of nucleotides linked together with the sugar phosphate groups serving as the backbone of the strands, and the nitrogenous bases held together in between by hydrogen bonds. What you should also remember is that the nitrogenous bases link up in very specific pairing. Adenine always to thymine, cytosine always to guanine. Again, adenine always to thymine, cytosine always to guanine. Right? Always that base pairing. Now, if we take the DNA molecule and uncoil it, like I've done here, makes it a little easier for learning replication, explaining and understanding replication. Because what happens during replication is that the DNA molecule strands, the hydrogen bonds between the bases, break and the strands uncoil. Now, it doesn't happen like a zipper exactly from top to bottom, but portions of the DNA strand will open up, creating bubbles of replication along its length. So what we have will then look like something like this. DNA strand, the nitrogenous bases held together by hydrogen bonds. There's a unwinding of this segment here, and in the following segment, distal to that, the bonds are still present and the DNA is not uncoiled. I'm going to use this segment only, magnified here, to explain DNA replication. Okay, so the first thing that's going to happen is that the enzyme DNA helicase is going to come along and unwind a segment of the DNA, creating the replication bubble. The unwound strands, the complementary strands of the DNA, will then serve as templates for building a new strand. So I've magnified this section here. The second thing that's going to happen is the enzyme DNA polymerase, represented by my little green man here. It's going to walk along each strand, adding nucleotides as dictated by the sequence of the template. DNA polymerase will grab the nucleotides it needs from the neoplasm and literally place them in one direction, going in one direction on one strand, and the opposite direction of the other. So it's going to place, it's dictated by base pair rule, guanine here, thymine here, and so forth. And on the other strand, it's going to place adenine here, and adenine here, and cytosine here. Again, dictated by the sequence of nucleotides on the template. Now the building is going in opposite directions. So what we have is the leading strand here is the one that's being built towards the replication fork, and the lagging strand here, which is being built away from the replication fork. Now the lagging strand is actually going to be built in segments because it has to wait for the DNA to continue to unwind so that it can work from the opposite end. What will happen at the end is that a third enzyme, DNA ligase, will come along and link these strands together so that we will get two new strands, each of which will have one old strand, one original strand that served as a template, and one new strand that was built by DNA polymerase. Because of that fact, we call the process semi-conservative replication. Each DNA is composed of one old and one new strand. Each new DNA molecule that is created is composed of one old strand and one new strand. That's replication.